Okay, so this is 6.3 part 2. So in this exploration, we're simply just looking at the signs of our trig functions here. So you know, just by graphing points, that in the first quadrant, your first and second quadrants, or first and second coordinates are both positive. You know in the second quadrant, you have to go negative and then positive. Third quadrant, you have both negatives. And of course, the fourth quadrant, you would go positively and then negatively. Now remember, when you're talking about those points, if you're on the unit circle, those points are cosine theta, sine theta. So what we're also talking about is the fact that in the first quadrant, both sine and cosine are positive, which means all of your 6 trig functions are positive, whether it's tangent, cotangent, secant, or cosecant. And then we have to go over here. The cosine would be negative. The sine would be positive. Of course, tangent would then be negative. The reciprocal of the cosine, which is secant, would be negative. And the reciprocal of the sine, oops, I think I misspoke. The reciprocal of the cosine, which is secant, is negative, and the reciprocal of the sine, which is cosecant, would be positive, and so on and so on. Tangent would be negative. I think I mentioned that. Now, when we come down here, though, since both sine and cosine are negative, that means your tangent and your cotangent are going to be positive, though, because a negative divided by a negative is positive. Okay, so if we go down here, basically what I just said, for the sine and the cosecant functions, sine are going to be positive in 1 and 2, because remember sine is the y, and that's both positive, and sine and cosecant will be negative in 3 and 4. If we do cosine and secant, remember cosine is the x, so cosine would be positive here, and it would be positive here, because how do I get to this quadrant? I have to go to the right positively. The x is positive. So that means obviously that the cosine and the secant would be negative in quadrants 2 and 3. For tangent, it's going to be positive in quadrant 1, and then tangent's going to be positive also in quadrant 3, because the sine and the cosine are both negative. So when I do my y over my x to get tangent, I'm going to have to get a positive, and it's going to be negative in those 2 quadrants. So make sure you have all those symbols right. So let's look at example 2. Name the quadrant in which the angle theta lies if the sine is positive. So I'm just going to kind of look at a picture, but the cosine is negative. Well, let's see. Sine is positive here and here, but we want the cosine to be negative. That would have to be here. So we're talking about quadrant 2. So you really got to make sure that you know those quadrants. All right, let's move on. We have some more identities. So this is another exploration. So we know this reciprocal identities already. We know that cosecant is 1 over sine, secant is 1 over cosine, and tangent or cotangent is 1 over tangent. We already knew those. Here are ones that I mentioned a little bit before, but let me give them to you again. So remember, tangent is y over x. But don't forget, the y, as long as we're on the unit circle, is the sine of theta, and the x is the cosine of theta. So another way to think of tangent is sine theta over cosine theta. So then cotangent would just be the reciprocal of that, because they're reciprocal identities. So cotangent would be cosine theta over sine theta. All right, so let's find the exact values using the identities when we're given the sine and the cosine. So here we are. I'm given the cosine and I'm given the sine. Now we're going to find the 4 remaining. Well, let's go ahead and do tangent theta. So remember, tangent theta is sine over cosine, so that would be root 10 over 10 over 3 root 10 over 10. The 10's on the bottom will cancel. So that would be root 10 over 3 root 10. Well, actually, the root 10's are going to cancel. So that would give me 1/3. So the tangent is 1/3. Which means that the cotangent would be the reciprocal of that, so that would be 3 over 1. Let's take care of that one. That's easy. Let's now do cosecant theta. So remember, cosecant is the reciprocal of the sine. So the reciprocal of the sine would be 10 over root 10. And if I multiply by root 10 over root 10 to get the radical out of the basement, I'm going to get 10 root 10 over 10, which is just root 10. And then if I quickly do the secant of theta, secant is the reciprocal of the cosine, so that's 10 over 3 root 10. Let's multiply by root 10 over root 10 to get rid of the radical. So that's going to give me 10 root 10 over root 10 times root 10 is 10, times 3 is 30. But then I can cancel this 10 into the 30, so I'm at the end going to get root 10 over 3. So you've got a lot of algebra to do there with your radicals. Lots of getting the radicals out of the basement. Remember, that's called rationalizing the denominator. All right, let's talk about another identity. This is called the Pythagorean identity. And it's based off the Pythagorean theorem. That's why it's called the Pythagorean identity. So using the idea that the equation of the unit circle is x squared plus y squared equals 1, because remember, unit circle has a radius of 1, we can come up with a new identity. So we're starting off with x squared plus y squared equals 1. Now, to translate that into trig, don't forget, x is really cosine theta. We can substitute sine theta in for y. And then here, all they did is they flip-flopped the two things that are being added. That's perfectly legal. So now, we don't write that as sine theta squared. When you square a trig function like that, it's actually written as sine squared theta plus cosine squared theta is equal to 1. So that's what it's talking about right here, how to write that. So the last line, the sine squared theta plus cosine squared theta equals 1, that is called the Pythagorean identity. Kind of like the granddaddy of all of them. It's the one that we use a lot. Now, there are a couple of variations that we can also come up with from that Pythagorean identity. Sine squared theta plus cosine squared theta equals 1. And we're going to look at those on this page. So here are the variations. If you start with sine squared theta plus cosine squared theta equals 1, and if I divide everything through by sine squared theta. Well, let's see. Sine squared theta divided by sine squared theta, that's 1. Plus cosine squared theta divided by sine squared theta. Remember, cosine divided by sine is cotangent squared theta is equal to 1 over sine squared theta is cosecant squared theta. Notice that is that identity. So here is another identity that you can get directly from your Pythagorean identity. if we go to this one and do basically the same thing, except we're not going to divide by sine squared theta, we're going to divide by cosine squared theta. Sine squared theta divided by cosine squared theta, that's tangent squared theta, plus cosine squared theta divided by cosine squared theta is 1, is equal to 1 over cosine squared is secant squared theta. That is another identity that comes directly from your original Pythagorean identity. So those are 3 identities that you use a lot. So let's play around with example 4 here. So if you look at this, it says find the exact value of each expression without using a calculator. So you just kind of have to use some manipulation here. So look, we know that 1 over cosecant squared is sine squared. So we're just going to change this to sine squared 35 degrees plus cosine squared 35 degrees. Well, remember what sine squared whatever theta is plus cosine squared whatever theta is, what does that equal? That's equal to 1. Therefore, sine squared 35 degrees plus cosine squared 35 degrees is also equal to 1. And you can plug that into your calculator to show you, but trust me, it's true. Let's look at this one. Cosine pi thirds over sine pi thirds. Well, what's cosine over sine? That is cotangent pi thirds minus cotangent pi thirds. Well, that's simply going to be 0. So there's just one way of using some of the identities that we've had so far. Okay, so now, if we look at number 5, if you're given that the sine of theta is negative 2/3, and here they tell you that theta is between pi and 3 pi halves. Now, if you're between pi and 3 pi halves, that means that you are in quadrant 3. Find the exact value of each of the remaining 5 trig functions, because of course they already gave us sine. Okay, now there are actually 2 different ways to do this, and I want to show you both ways. The first one says do it using a circle. This, quite honestly, is the way that I prefer to do it. We'll see. I'll show you both ways and you guys can decide. So it says that I'm in quadrant 3, so I'm going to draw myself a right triangle in quadrant 3. It says my sine is negative 2/3. Think of SOHCAHTOA. Sine of this angle, the angle is always attached to the origin, is opposite over hypotenuse. So that means that this is negative 2 and this is 3. You always put the hypotenuse as the positive one. How do I find this third side? Well, I need it. I'm going to go ahead and I'm going to use my Pythagorean theorem. And if you use your Pythagorean theorem, you're going to see that this is root 5. But of course, it's negative because in the third quadrant, I would go to the left negatively as well as down negatively. So now I can literally just use SOHCAHTOA to find my trig function. Sine, we already know, is negative 2/3. So what is the cosine of theta? Well, cosine of theta is adjacent over hypotenuse. So that would be negative root 5 over 3. Tangent of theta is opposite over adjacent. So that's going to be positive 2 over root 5. Of course, get the radical out of the basement. And you're going to get 2 root 5 over 5. Now to find the other ones, those are just the reciprocals. So cosecant of theta would be the reciprocal of sine, so that's negative 3 over 2. Secant of theta would be, well, remember secant is 1 over the cosine, so that's negative 3 over root 5, but get the radical out of the basement. So that's negative 3 root 5 over 5. And then, of course, cotangent, that would be cosine. Cotangent of theta would be equal to the reciprocal of the tangent, and the reciprocal of the tangent would be positive root 5 over 2. And you found all of them. So option 2 is to use your identities. So the identity that you would use would be sine squared theta plus cosine squared theta is equal to 1, your Pythagorean identity. What you would do is you would toss in your sine. So that would be negative 2/3, but since it's sine squared, you'd square it, plus cosine squared theta equals 1. Negative 2/3 squared would be 4/9, plus cosine squared theta equals 1. If I subtract 4/9 from 1, I'm going to get 5/9. And then if I go ahead and square root both sides, that means that cosine of theta is root 5 over root 9, but root 9 is 3. Now remember, it's plus and minus, but because I'm in the third quadrant, it's going to be the negative one. So instead of drawing a picture and using SOHCAHTOA, here's another way to find the cosine. And of course, once you have that, then you would use the exact same way that I would do up here to find your other one. So you would take, for example, to find tangent theta, you would take sine theta over cosine theta, which would be, what was sine theta again? Negative 2/3 over negative root 5 over 3. So the 3's cancel. 2 negatives make a positive. Get the radical out of the basement, and you would get 2 root 5 over 5. So that would be your tangent, which is, of course, exactly what I got up there. And then you would just do the reciprocal to find the other ones. All right, we're going to go on to part 3.